starting with number 12. This says solve by factoring. Enter your smaller root first, followed by a comma, and then your larger root. Okay, so I know if I want to solve by factoring, it needs to say equals 0 before I begin, and it doesn't. So I'm going to move the 49 by subtracting it, and of course I have to do that to both sides. So 49 minus 49 makes 0, and then the left side you can't combine those because one has an x squared and one doesn't, so it just stays x squared minus 49. Okay, well when you factor, your first rule is to look for a GCF. But there is not one. They don't both have x's and nothing can divide into them besides a 1. Then, if there's two terms, 1, 2, I want to see if it's this thing called a difference of squares. And it is. It's got a minus sign, which makes it a difference. 49 is a perfect square, and so is x squared because of the even exponent. So it is a difference of squares. Every time you have a difference of squares, you set up two sets of parentheses. One gets a plus, and one gets a minus. And then you take the square roots. The square root of x squared is x, because x times x is x squared. And the square root of 49 is 7, because 7 times 7 is 49. And then this equals 0 that we have going on, I need to bring him down. Once you get the problem factored, you have to set your factors equal to 0 and solve. So I'm going to set x plus 7 equal to 0. And then I'm going to take my other factor, which is x minus 7, and set it equal to 0 also. And then I'm just going to solve these two equations. So to solve the first one, I get rid of addition of 7 by subtracting. And then 0 minus 7 is negative 7. And to solve the other one, I get rid of subtraction of something by adding. So I'm going to add 7 to both sides, and 0 plus 7 is 7. Now, this is asking you to enter your smaller root first, followed by a comma, and then your larger root, no spaces. So which is the smallest answer? Negative 7, then a comma, then the positive. No spaces. So that's how you would enter it. So smallest answer, comma, biggest answer. All right, number 13. This says solve this equation by factoring, and we're going to enter it the same way. Smaller root, comma, larger root. Okay, it needs to say equals 0, and it does not say equals 0, so I need to fix it. So to get rid of this positive 6, I'm going to have to subtract it. So now 6 minus 6 makes 0. And then the left side, I can't do anything with that, so I'm going to drop it, drop it, drop it. So I'm going to drop the 5x squared, I'm going to drop the plus 13x, and I'm going to drop the minus 6. Okay, at this point, I'm going to factor it. So first rule is to look for a GCF. So I look to see if something can divide into 5, 13, and 6, and nothing can. Then they don't all have x's, so there's no GCF. Then I count that there's 1, 2, 3 terms, so I am going to a times c rooftop it. All right, so when I take a times c, I'm taking 5 times negative 6, and that makes a negative 30. And I want the numbers to add to make b, which is the guy in the middle, so I want them to add to make 13. So I'm looking for two numbers that multiply to make negative 30 and add to make 13. Okay, if you need calculator assistance, you type into your y equals what you want them to multiply to be, which is negative 30 divided by x. Then you go to your table and you hunt for the two numbers across from each other that add to make 13. And these happen to be the ones. Negative 2 plus 15 is 13. Okay, so it's a negative 2 and it's a positive 15. All right, so now I'm going to drop, replace, drop. Drop the 5x squared. Replace the 13x with these numbers. Minus 2, don't forget his x because the middle guy has an x. Plus 15, don't forget his x because the middle guy has an x. And drop the negative 6. Drop, replace, drop. Drop, replace, drop. Now that we have 4 terms, 1, 2, 3, 4, we factor by grouping. So I group together my front 2 terms and I take their GCF out. Well, the only thing they both have is an x. Build your parentheses and get both of those back. So x times what is 5x squared? X times 5x is 5x squared. X times what is negative 2x? X times negative 2 is negative 2x. Then I'm going to look for the GCF out of my back half. And do you know what the greatest number is that can go into 15 and 6? It's a 3. But let's say you didn't know that. Do you remember that whatever you write here, you copy here? Because they have to be the same. They can't look different. And then whatever this symbol is goes here. Now let's just make sure it works, because this needs to distribute to give me what I see above. So let's see. Does 3 times 5x make 15x? Yes. Does 3 times negative 2 make negative 6? Yes. Okay, so I'm going to build my 2 set of parentheses. Whatever was in both of those parentheses, you write it one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, you write in the other set of parentheses. So x plus 3. Now, if all I was asked to do was to factor, I'd be done. Unfortunately, I was asked to solve. So this equals 0 business, I need to bring that equals 0 business down. And now I need to set each factor equal to 0. So I'm going to take my first factor, 5x minus 2, and set it equal to 0. And then I'm going to take my second factor, x plus 3, and set it equal to 0. And then all I have to do is solve these 2 equations. Let's do the one step first. To get rid of addition, we subtract. And 0 minus 3 is negative 3. Okay, now let's do the 2-stepper. So to get rid of subtraction, we add. So I'm getting rid of subtraction of 2 by adding it. The 5x will drop. 0 plus 2 is 2. And then I undo multiplication with division. So I'm going to divide both sides by 5. You can't divide 2 by 5, nor can you reduce it. So it just stays like that. So when it tells you to enter your smaller root first, you're going to write negative 3, comma, and then your biggest one, which is 2/5. And that would be how you type it into your computer. So smaller root or smaller answer, comma, bigger answer. And I know a negative is always smaller than a positive, so that's why the negative 3 went first. Okay, and next page. All right, this one says to solve by graphing. Okay, well that's the easiest way. To solve by graphing, I want to graph it and see where it touches the x-axis. Do make sure it says equals 0 or equals y to begin with. As long as it does, you're good to go. Okay, so I'm going to type this equation in. So x squared plus 2x minus 3. And I'm going to graph it and see where it looks like it touches the x-axis. So that looks like a 1. That looks like a negative 3. So to know for certain, I'm going to go to the table. And negative 3 is an answer because there's a 0 in the y column. And 1 is an answer because there's a 0 in the y column. That's why they're called zeros also. So negative 3 is an answer and 1 is an answer. So since negative 3 is an answer and 1 is an answer, then in the computer it tells you to enter your smaller root first, which would be negative 3, comma, your bigger root, 1. And that's how I would type that in. Okay, next one. This says consider this quadratic function. It says find the y-intercept and the equation to the axis of symmetry. Okay, we haven't done a y-intercept yet today. Well, that's 0, comma, c. That's super easy. So 0, comma, c, remember a's in front of the x squared, b's in front of the x, and c's the constant. So that means it would be 0, comma, negative 8. So who has a y-intercept of 0, negative 8? This one says the y-intercept's a positive 8, so that one's out. This one says the y-intercept's 5/4, so that's out. Okay, that one has a negative 8. That one doesn't have a negative 8, so that's out. So it is C. I don't even need to do anything else. If I was to do the axis of symmetry, then I would do x equals opposite of b over 2 times a, which I've already done a few times already. All right, now number 16. You could remember rules to figure this out, or you could kind of do it the long way. I'm going to show you the long way in case you don't remember a shortcut. So this means you're taking I times itself 7 times. 1, 2, 3, 4, 5, 6, 7. So we're just going to work this out piece by piece. I times I is I squared. I times I is I squared. I times I is I squared. And then I still have an I left. Okay, now do you remember how earlier I told you that I squared is negative 1? So this is a negative 1 times a negative 1 times a negative 1 times an I. So what's negative 1 times negative 1? Positive 1. What's positive 1 times negative 1? Negative 1. And what's negative 1 times I? A negative 1i or a negative I. And so that makes it answer choice A. Okay, number 17. I need to multiply these 3 together, and it doesn't matter if I multiply the front 2 together first, the back 2 together first, the first and last together. It doesn't matter. Most of you would probably multiply in the order you see it. So negative 5 times negative 6i is a positive 30i. And then you need to multiply that with the 7i in the back. So 30i times 7i is 210i squared, because 30 times 7 is 210, and I times I is I squared. Well, remember, I squared has a value of negative 1, so 210 times negative 1 is negative 210. And that makes your answer choice C. Okay, we have 2 left to go. Almost there. All right, we need to simplify this radical. So when a square root is over the whole fraction, what it really means is the square root is over the numerator, and the square root is also over the denominator. Well, first I'm going to look to see if either of those are perfect squares. And I know that 49 is a perfect square. What is the square root of 49? 7. So I want a 7 in the denominator. Unfortunately, they all have that, so I can't rule anything out, but that's okay. So now I need to find the largest perfect square that can go into 192. So think about your perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, etc. I want to try to find the biggest perfect square that can divide into 192 evenly. Now there's different ways of doing this. I'm going to take 192 and I'm going to start dividing by numbers in this list. 1 can go into everything, so I skip it. Now, if your answer can be divided by any of these perfect squares, you need to keep going. And I know 48 can be divided by 4 and 16, so I need to keep searching. So I would try 192 divided by 9. 9 doesn't work. Let's try 192 divided by 16. That works. Now, can your answer be divided by any of these? Yes. 12 can be divided by 4, so that means there's a bigger perfect square than 16 that can go in. Let's try 192 divided by 25. Nope, got a decimal. 192 divided by 36. Nope, a decimal. 192 divided by 49. Nope, a decimal. 192 divided by 64. Now, can 3 be divided by any of those? Only the 1. And so, because 1 can go into everything, It's like it doesn't count. So this is the largest perfect square that goes in, and it goes in 3 times. So I rewrite this as the square root of 64 times the square root of 3. So 64 is the largest perfect square that goes in, and it goes in 3 times. Well, what is the square root of 64? 8. Recopy the square root of 3, recopy the division bar, recopy the 7. And that's your answer. So that is answer choice A. Okay, this next one is asking me to graph this. So first, let's notice our A. Our A is a negative number. Anytime A is a negative number, the graph is going to open down. So that means answer choice C and D are out of here. Now, I can put this in my calculator. I could find the axis of symmetry. By hand, I could do lots of things. I'm going to use my calculator. So let's type it in. Negative 2x squared plus 5x plus 2. And graph. And does it look like A or does it look like B? It looks like A. So A is our answer. All right, and that is your review to the Unit 5 Part 1 test. Good luck. Smiley face.